Hello there, and welcome. Tonight I want to take you somewhere very far away and yet impossibly close. Somewhere that exists in the space between your eyes and the farthest star, somewhere that lives in the gentle darkness just beyond the edge of what you can see. I want to take you on a journey through light itself, through the quiet pathways it travels, through the cosmic corridors it might be wandering even now as you settle into your pillow and let the weight of the day drift slowly away from your shoulders. This is not a journey that requires anything from you except your presence, your willingness to wonder, and perhaps your permission to let your eyes grow heavy as we travel together through the beautiful mysteries of the universe. Wherever you are right now, whatever time the clock on your wall might show, you are exactly where you need to be for this journey. Perhaps it is late evening where you are, and the world outside your window has grown quiet with the particular silence that comes when most of humanity has closed their eyes. Perhaps it is the deep hours of the night, those tender moments when time itself seems to slow down, and the boundary between waking and dreaming grows thin and permeable. Or perhaps you are somewhere where morning is just beginning to think about arriving, and you are giving yourself this gift of rest before the day asks anything of you. Wherever you are, whatever time zone holds you in its gentle embrace tonight, I want you to know that you are welcome here, that this space we are creating together is meant for you, and that the universe we are about to explore has been waiting patiently for your attention. I would love to know where you are listening from tonight. There is something beautiful about imagining all the different places where these words might be landing, all the different windows looking out on different skies, all the different pillows cradling different heads as we begin this journey together. If you have a moment, perhaps you might leave a small note telling me where, in the world you are resting tonight, what time it is in your corner of the planet, what the sky looks like from where you are lying. These small connections remind me that we are all sharing the same cosmos, all looking up at the same stars even if we see them from different angles, all wondering about the same mysteries even if we phrase our questions in different languages. And if this journey brings you peace tonight, if it helps carry you gently towards sleep and through the quiet hours until morning, perhaps you might consider staying with me for future wanderings through the cosmos. There is so much more to explore together, so many more mysteries waiting in the darkness between the stars, and I would be honoured to have your company on those journeys as well. But for now, let us begin with something that seems so simple, so fundamental, so obvious that we rarely stop to question it. Let us begin with light, the light that is reaching your eyes right now. Whether it comes from a screen or a lamp or the soft glow of stars through a distant window has travelled to meet you. It has crossed some distance, however small or vast, to arrive at this exact moment in this exact place where you happen to be resting. This is something we take for granted, this constant arrival of light, this endless streaming of photons that brings us information about the world and the universe beyond. Light travels, light arrives, light shows us what is there to be seen. It seems so straightforward, so reliable, so predictable. And yet tonight I want to invite you to consider a possibility that might at first seem strange, perhaps even a little unsettling, but which I promise will become peaceful and wonder-filled as we explore it together. What if light, that most constant and reliable of cosmic messengers, sometimes took detours on its way to our eyes? What if the starlight that we see tonight, the ancient photons that have travelled for thousands or millions or billions of years to reach us, had wandered through hidden corridors of space-time, had taken scenic routes through dimensions we cannot perceive, had arrived late to our reality because the universe is far more complex and mysterious than we have ever imagined? It is a question that might seem fanciful at first, the kind of speculation that belongs more to science fiction than to the serious study of the cosmos. I understand that skepticism, and I honour it. Science has given us an extraordinary understanding of light, of its speed and its behaviour and its fundamental nature. We have measured the speed of light with exquisite precision. We have sent it bouncing off mirrors on the moon and timed its return to fractions of a second. We have built our entire understanding of the universe on the assumption that light travels at a constant speed through the vacuum of space, taking the most direct path from source to observer, arriving precisely when the mathematics of distance and velocity say it should arrive. And yet there is something beautiful about pausing at the edge of what we know and peering into the darkness beyond. There is something wonderful about acknowledging that the universe is far larger and stranger than our current understanding can contain. What if, just maybe, there are aspects of light's journey through the cosmos that we have not yet discovered? What if the photons arriving at your eyes tonight have stories to tell that we do not yet know how to hear? What if reality itself is more layered, more complex, more mysteriously beautiful than even our most sophisticated instruments have revealed? This is not about doubting science or dismissing the extraordinary achievements of human knowledge. This is about something else entirely. This is about wonder. This is about allowing ourselves to sit at the boundary between the known and the unknown and feel the gentle pull of curiosity. This is about remembering that the universe has surprised us before, that discoveries we never anticipated have reshaped our understanding again and again throughout history, and that there is no reason to believe that the age of cosmic surprises has ended. So tonight, as you lie there in the comfortable darkness, as your breathing grows slower and deeper and more rhythmic, I invite you to come with me on a journey through a possibility. We are not going to prove anything tonight. We are not going to make definitive claims about the nature of reality. Instead, we are going to wonder together. We are going to let our minds wander through the vast and quiet spaces between the stars. We are going to consider what it might mean if light, that fundamental messenger of the cosmos, sometimes took the long way home. Let us begin by remembering just how strange light already is, even before we start imagining additional mysteries. Light is perhaps the most peculiar thing in the universe, a phenomenon so bizarre that even after centuries of study, it continues to challenge our intuitions about how reality should work. Light behaves as both a wave and a particle, spreading out through space like ripples on a pond while also arriving at its destination as discrete packets of energy called photons. This dual nature, this refusal to be pinned down to a single identity, is one of the foundational mysteries of quantum physics, a mystery that the greatest minds of the 20th century struggle to understand, and that we still, in many ways, find deeply puzzling. When you look at a distant star, what is actually happening? Photons that were emitted from the nuclear furnace at that star's core, perhaps thousands or millions of years ago, have been travelling through the vast emptiness of space ever since. They have crossed distances so immense that our minds cannot truly comprehend them, passing through the dark voids between galaxies, streaming past countless other stars and planets and cosmic objects, never stopping, never slowing, never deviating from their path until finally, after all that unimaginable journeying, a handful of them happen to enter the small opening of your eye and trigger a cascade of signals in your retina that your brain interprets as a tiny point of light in the night sky. This is already miraculous. This is already so strange and wonderful that we should never become too accustomed to it. You are receiving messages from across the universe every time you look up at the stars. But here is where our contemplation tonight begins to deepen. We assume that those photons took the straightest possible path from their source to your eye. We assume that light, travelling at its constant speed of approximately 299,792 kilometers per second, crossed the intervening space in the most efficient manner possible. This is how we calculate the distances to the stars. This is how we determine the age of the light arriving from distant galaxies. This is how we map the universe and understand our place within it. We trust that light is a reliable messenger, that it tells us the truth about when and where events occurred in the cosmos, that its arrival time is a faithful indicator of the distance it has travelled. And for most purposes, this trust is well-founded. The predictions of physics based on this assumption have been confirmed again and again by observation and experiment. The universe behaves, in most of the ways we can measure, exactly as we would expect if light travelled in straight lines at constant speed through the vacuum of space. This is not a mystery we're going to solve tonight, and it would be presumptuous to claim that we have discovered something that has eluded the brilliant minds who have devoted their lives to studying the nature of light and space. But I want to invite you to consider a gentle possibility, a quiet speculation that might be true or might simply be a beautiful idea to carry with you as you drift towards sleep. What if our measurements, as precise as they are, only capture light that took the direct path? What if there is other light that set out from the same sources at the same moments, that wandered through hidden dimensions or followed curved pathways through the complex geometry of spacetime, and that is still making its way toward us even now, carrying slightly delayed images of cosmic events we thought we had already witnessed? This is not as far-fetched as it might initially seem. We already know that space itself is not the simple, flat, empty stage that our everyday intuitions suggest. Einstein showed us over a century ago that space and time are woven together into a fabric called spacetime, and that this fabric can be curved and stretched and warped by the presence of mass and energy. The massive objects in the universe, stars and planets and galaxies and black holes, create dips and valleys in this fabric, and light follows these curves as it travels. This is not speculation. This is established physics, confirmed by countless observations. Light from distant galaxies is bent by the gravity of closer galaxies that lie between us and them, creating the phenomenon known as gravitational lensing, where we can sometimes see multiple images of the same distant object, or where the light from that object is smeared out into rings and arcs of distorted brilliance. So we already know that light does not always take the straightest path in the simplest sense. It follows the contours of space-time, and those contours can be quite complex. But what if the complexity goes even deeper than we have yet discovered? What if there are folds and tunnels and hidden dimensions in the fabric of space-time that we have not yet detected? Pathways that light can sometimes wander down, detours that add time to its journey without adding apparent distance to its path. I'm not going to tell you that this is definitely true. I'm not going to claim that scientists have proven the existence of such cosmic detours. What I'm going to do is invite you to hold this possibility gently in your mind, like a beautiful speculation, like a maybe that makes the universe feel even more vast and mysterious than it already is. Because there is something deeply peaceful about acknowledging how much we do not know, about recognizing that the cosmos almost certainly contains wonders beyond our current imagination, about allowing ourselves to wonder without demanding immediate answers. Think about where you are right now, the small and specific location where your body is resting as you listen to these words. You're on a planet, a rocky sphere spinning gently through space, orbiting a star that is itself moving through the galaxy, which is itself drifting through the vast cosmic web of galaxies that makes up the large-scale structure of the universe. You're moving through space at tremendous speeds, even though you feel perfectly still. You're bathed in light from countless sources, most of which you cannot see, light that is passing through you and around you, and past you at this very moment on its way to destinations you will never know. The universe is alive with light, with photons streaming in every direction, carrying information about stars being born and stars dying, about galaxies colliding and galaxies drifting apart, about events that happened billions of years ago, and events that, by the standards of cosmic time, are happening right now. And somewhere in all that light, perhaps there are photons that have taken the long way around. Perhaps there are messengers from distant cosmic events that are still winding their way through the complex geometry of space-time, still navigating the hidden pathways and extra dimensions that might exist folded into the fabric of reality, still making their journey toward eyes that may or may not be watching when they finally arrive. If this is true, then the universe is even more layered and mysterious than we imagined. If this is true, then the sky we look up at is not just showing us the past, but multiple versions of the past, arriving at different times, depending on the paths the light has taken to reach us. But even if this is not literally true, even if light always takes the most direct route, and our measurements have captured everything there is to capture, there is still something valuable in contemplating the possibility. It reminds us to hold our certainties lightly. It reminds us that the universe is under no obligation to be simple or easily comprehensible. It reminds us that wonder is a worthy state of mind, that curiosity is a gift we can give ourselves, that the cosmos is vast enough to contain mysteries we have not yet begun to suspect. As you lie there, breathing slowly, letting your body grow heavier and more relaxed, I want you to imagine the light that is reaching you right now. Some of it has travelled only a short distance, from the lamp across the room or the screen in your hands. Some of it has travelled much farther, from the stars outside your window or the distant galaxies that lie beyond the edge of naked eye visibility. And all of it, every single photon that reaches your eyes, has made a journey to be here with you in this moment. Each one is a tiny messenger, a carrier of information about the universe, a connection between you and the source that emitted it however long ago. Perhaps some of those photons took detours. Perhaps some of them wandered through hidden dimensions or followed curved paths through this complex geometry of space-time. Perhaps some of them are arriving late, carrying images of events that we thought we had already accounted for, adding new layers to our understanding of when and where things happened in the cosmos. Or perhaps not. Perhaps light is simpler than this speculation suggests, and every photon takes the most direct route possible, arriving exactly when the mathematics predicts it should. Either way, there is something peaceful about the contemplation. Either way, we are reminded that we live in a universe of almost unimaginable vastness and complexity. Either way, we are invited to feel small in the best possible sense, to recognize our place in the cosmic order not as insignificant, but as part of something far larger and more mysterious than we can fully comprehend. This is what I want to offer you tonight. Not answers, but questions. Not certainties, but possibilities. Not facts to memorize, but wonders to carry with you as you drift towards sleep. The universe is speaking to us all the time, in the language of light, in the whispers of photons that have crossed unimaginable distances to reach our eyes. And maybe, just maybe, some of those whispers are taking the scenic route, wandering through the hidden pathways of the cosmos, arriving fashionably late to the reality we think we know. Let this thought be a companion to you as you rest. Let it float gently at the edge of your awareness, not demanding attention, not requiring belief, just present as a beautiful possibility in a universe that has room for so many beautiful possibilities. The light is travelling, the photons are on their way. Some of them might be taking detours through the vast and quiet architecture of space-time, and you are here, in this moment, receiving whatever messages the universe has chosen to send you tonight. There is no hurry. There is no destination we must reach before morning. This journey through the mysteries of light is meant to be slow and meandering, meant to mirror the contemplative pace of the cosmos itself. Stars take millions of years to form. Galaxies take billions of years to evolve. Light from the most distant objects we can observe has been travelling for almost the entire history of the universe to reach us. In the face of such vast timescales, what is the rush? Why not let ourselves drift slowly through these ideas, savouring each one, allowing them to wash over us like gentle waves on a cosmic shore? And so we will continue, in the chapters to come, exploring the nature of light and the mysteries of its journey through space. We will look at what humanity has discovered about this fundamental aspect of reality, and we will consider the speculations and possibilities that lie beyond the edge of current knowledge. We will travel together through the quiet darkness between the stars, wondering about the hidden pathways that light might follow, contemplating what it would mean if reality were even more layered and complex than we have yet imagined. But for now, just rest in this moment. Let your breathing continue its slow and steady rhythm. Let your body sink more deeply into the surface that supports you. Let your mind grow quieter, not forcing thoughts away, but simply allowing them to settle like sediment drifting to the bottom of a still pond. The universe is vast, the mysteries are endless, and you are here, a small but precious part of it all, receiving the light that has travelled so far to reach you. Perhaps tonight, as you sleep, you will dream of photons on their endless journeys. Perhaps you will imagine yourself drifting alongside them through the dark spaces between stars, following the curved pathways of space-time, exploring the hidden dimensions that might be folded into the fabric of reality. Perhaps you will feel the peace that comes from knowing that you are connected to everything, that the light reaching your eyes has come from all corners of the cosmos, that you are never truly alone in this vast and wandering universe. The light is travelling. It has always been travelling. It will continue travelling long after we are gone. And somewhere in all that endless motion, somewhere in the vast choreography of photons streaming through space, there might be detours and wanderings and late arrivals that we have not yet begun to understand. This is not a cause for concern. This is an invitation to wonder. This is a reminder that the universe is far more mysterious and beautiful than we can imagine, and that the questions we ask are as valuable as any answers we might find. Welcome to this journey through the wandering light. Welcome to this contemplation of cosmic mysteries. Welcome to this quiet and peaceful exploration of what might be. I am honoured to have you here with me tonight, wherever you are in the world, whatever time it is in your corner of the cosmos. Let us continue together, slowly and gently, deeper into the wonder. The night is long and full of stars. Each one is sending light toward you, light that has been travelling for years or centuries or millennia, light that might have taken the straightest path or might have wandered through hidden corridors of space-time. You are receiving all of it, whether you're aware of it or not. You're a destination for countless photons, a meeting point for messages from across the universe. And as you rest here, as you let go of the day and prepare to drift into sleep, you can take comfort in that connection. You are part of this. You belong to the cosmos that is sending you its light, and the cosmos, in some sense, belongs to you as well. Let this be the thought that carries you forward into the next movement of our journey. Let this be the foundation on which we build our exploration of light and its mysteries. You are connected to everything. The light is always travelling, and somewhere out there, in the vast and quiet darkness between the stars, the universe is full of wonders we have not yet discovered. Rest now, breathe slowly, and let us continue, together, into the gentle mystery of the wandering light. The transition between wakefulness and sleep is itself a kind of journey, a passage from one state of consciousness to another. As you make that passage tonight, you carry with you the beginnings of a cosmic contemplation, the first threads of a wonder that will continue to unfold in the chapters to come. There is no need to hold on to these ideas tightly. There is no need to remember every word or follow every thought to its conclusion. Simply let them wash over you. Let them become part of the atmosphere of this quiet night. Let them mingle with your dreams and your drifting thoughts as you move toward rest. The light that reaches us from the stars is ancient beyond comprehension. Some of it began its journey when dinosaurs still walked the earth. Some of it set out before our planet even existed. And some of it, if our gentle speculation has any truth to it, might still be winding its way through the complex pathways of space-time, taking detours we cannot see, arriving at destinations we cannot predict. This is the universe we live in. This is the cosmos that surrounds us and includes us, and invites us to wonder about its deepest nature. And you are here, in this moment, part of all of it. Your consciousness, your awareness, your capacity to wonder, these are themselves cosmic phenomena, emergent properties of matter and energy that have been organized in particular ways by billions of years of evolution on this small planet orbiting this ordinary star in this typical galaxy in this particular corner of the visible universe. You are the cosmos contemplating itself. You are stardust that has learned to ask questions about starlight. And that, perhaps, is the deepest mystery of all. But we will save those contemplations for another time. For now, let us simply rest in the wonder of light, in the mystery of its journey, in the possibility that its pathways through space might be more complex and beautiful than we have yet imagined. Let us hold these ideas gently, without grasping, without demanding certainty, without needing to resolve every question before we can find peace. The universe is patient. The stars have been shining for billions of years and will continue for billions more. The photons are streaming through space, some taking the direct route, some perhaps wandering through hidden dimensions, all of them carrying information about the cosmos that created them. And you're here, receiving their light, wondering about their journey, letting their ancient messages wash over you as you prepare to sleep. This is enough for now. This is more than enough. This is the beginning of a contemplation that could last a lifetime, that could deepen with every night you spend looking up at the stars, that could bring you peace and wonder and a sense of connection to something far larger than yourself. Let the light travel. Let it wander. Let it take whatever detours the universe has prepared for it. And let yourself rest, knowing that you are part of the same vast and beautiful cosmos that the light is exploring. We will continue soon, but for now, just breathe, just rest, just let the wonder be. In the spaces between these words, in the pauses between these thoughts, there is room for you to drift. There is room for your mind to wander in whatever direction it wants to go. There is room for the ideas we have explored to settle into your consciousness at whatever depth they find comfortable. This is not a lecture or a lesson. This is a contemplation, a meditation, a gentle invitation to wonder about the nature of light and the mysteries of its journey through space. And as you wonder, as you drift, as you let go of the need to understand everything right now, you may find that a certain peace begins to settle over you. The peace that comes from knowing that the universe is vast and mysterious and beautiful. The peace that comes from recognizing that you are part of something far larger than yourself. The peace that comes from accepting that there are questions we may never answer and that the asking is itself a kind of gift. The light is traveling. It has been traveling since the first stars ignited in the young universe. It will continue travelling until the last stars fade and the cosmos grows dark and cold. And in the meantime, it is reaching you, touching your eyes, carrying messages from across the immensity of space. What a privilege it is to be a receiver of such messages. What a wonder it is to be part of a universe that communicates with itself through the endless streaming of photons. Perhaps some of those photons have taken detours. Perhaps some of them have wandered through hidden dimensions or followed curved pathways through this complex geometry of spacetime. Perhaps the light reaching you tonight carries not just images of the past, but images of multiple pasts layered and overlapping, each one arriving at its own pace depending on the path it took through the cosmos. Or perhaps not. Perhaps light is simpler than this, more straightforward, more predictable. Perhaps our measurements have captured everything there is to capture, and the universe holds no surprises in this particular domain. Either way, the wonder remains. Either way, the mystery of light's journey from star to eye is profound and beautiful and worthy of contemplation. Either way, you are here, receiving the cosmos's messages, wondering about their meaning, letting them carry you gently towards sleep. This is the gift of this night. This is the invitation that the universe extends to anyone willing to look up and wonder. Not answers, but questions. Not certainties, but possibilities. Not the end of mystery, but the beginning of an endless exploration that can last as long as you're willing to keep wondering. And so, we rest here, at the end of this first chapter, at the threshold of deeper explorations to come. The light is travelling, the questions are multiplying, and you are here, beautifully and improbably here, part of the same cosmos that is sending you its light from across the unimaginable distances of space. Sleep well, wanderer. Dream of photons on their endless journeys. And know that when you wake, the universe will still be here, still full of mysteries, still inviting you to wonder about the light that reaches your eyes and the paths it might have taken to arrive. The journey continues. The wandering never ends. And somewhere out there, in the vast and quiet darkness between the stars, the light is still travelling, still wandering, still making its way toward destinations it cannot know. Throughout the long story of human existence, we have been creatures of light. Before we understood anything about its nature, before we had words or theories or instruments to study it, we knew light in the most immediate and visceral way possible. We knew it as the difference between day and night, between safety and danger, between the warmth of the sun on our skin and the cold mystery of the darkness. Our earliest ancestors gathered around fires not just for warmth and protection, but because light was life, was community, was the visible presence of something that pushed back against the vast and terrifying darkness of the world. And so perhaps it is no surprise that throughout human history, light has been associated with the divine, with knowledge, with consciousness itself. In nearly every culture that has left us records of its beliefs, light appears as a symbol of enlightenment, of truth, of the presence of gods or spirits or cosmic forces that order the universe. We speak of being illuminated when we understand something new. We describe brilliant people as bright. We associate darkness with ignorance and evil, light with wisdom and good. These are not accidents of language. They are reflections of a deep intuition that light and understanding are somehow connected, that to see clearly is to know truly. But what is light actually? What is this phenomenon that we have revered and celebrated and depended upon since the very beginning of our species? The answer to this question has taken humanity thousands of years to develop, and even now, after all our discoveries and theories and experiments, there remain aspects of light that puzzle and surprise us. This is part of what makes it such a worthy subject for contemplation. Light is both the most familiar thing in the world and one of the most mysterious. For most of human history, we had no idea that light travelled at all. It seemed to appear instantaneously whenever its source was revealed. You light a candle, and the room is immediately filled with its glow. You open a shutter, and sunlight floods through the window without any perceptible delay. The idea that light might take time to move from one place to another would have seemed strange to our ancestors, a needless complication of something that appeared perfectly simple. The first hints that light had a finite speed came from observations of the cosmos, as so many deep truths do. In the 17th century, the Danish astronomer Ole Rømer was studying the moons of Jupiter, those small worlds that Galileo had discovered just decades earlier with his revolutionary telescope. Rømer noticed something peculiar about the timing of these moons' orbits. When Earth was closer to Jupiter, the moons seemed to complete their orbits slightly faster than expected. When Earth was farther from Jupiter, they seemed to move slightly slower. After careful analysis, Römer realized what was happening. The moons were orbiting at a constant rate, but the light carrying information about their positions was taking different amounts of time to reach Earth depending on the distance it had to travel. Light had a speed, and that speed, while enormous, was not infinite. This was a profound discovery, though it took time for its full implications to sink in. If light had a finite speed, then the universe was not as immediate as it appeared. When you looked at a distant star, you were not seeing it as it was right now, but as it was however long ago the light left its surface. The stars themselves might have changed or moved or even died in the time it took their light to reach us. The night sky was not a snapshot of the present, but a collection of messages from the past, each one sent at a different time depending on the distance of its source. Over the following centuries, scientists worked to measure the speed of light with increasing precision. The numbers were staggering. Light travels at approximately 290 kilometers per second in a vacuum, a speed so immense that it can circle the entire Earth more than 7 times in a single second. Nothing we know of can travel faster. This speed limit seems to be built into the very fabric of reality, a fundamental constant that appears in the equations governing everything from the behavior of atoms to the structure of the cosmos. But knowing the speed of light only deepened the mystery of what light actually is. By the 19th century, scientists had developed 2 competing theories. One held that light was a wave, like sound or ripples on water, a disturbance that propagated through some medium. But what medium? Sound waves travel through air, water waves travel through water. What did light waves travel through? Scientists proposed a substance called the luminiferous ether, an invisible and intangible medium that supposedly filled all of space and served as the carrier for light waves. The other theory held that light was made of particles, tiny corpuscles that were emitted by sources and absorbed by detectors, travelling in straight lines like miniature bullets. Experiments seemed to support both theories, which should have been impossible if light was simply one thing or the other. Light could be made to interfere with itself, producing patterns of bright and dark bands that only made sense if it were a wave. But light also came in discrete packets of energy, and when it struck certain materials, it behaved as if it were a stream of particles. The resolution to this paradox came in the 20th century, with the development of quantum mechanics. But the resolution was perhaps stranger than the paradox itself. Light, it turns out, is neither simply a wave nor simply a particle. It is something that has properties of both. Something that behaves as a wave when we set up experiments to detect wave behaviour, and as particles when we set up experiments to detect particle behaviour. The photon, as we now call the quantum of light, is a fundamental entity that defies our everyday intuitions about what things can be. It is, in some sense, a vibration in the electromagnetic field, but it is also a discrete unit of energy that can be counted and measured as if it were a tiny object travelling through space. This quantum nature of light has profound implications that we are still working to fully understand. When a photon is emitted from a source, it does not follow a single definite path to its destination. Instead, in the mathematical framework of quantum mechanics, it exists in a superposition of all possible paths, each one contributing to the probability of where the photon will ultimately be detected. When we detect the photon, the superposition collapses and we find the photon at a specific location. But before that detection, the photon was, in some sense, everywhere it could possibly have been, exploring all routes simultaneously. This is already a form of wandering, a form of taking all possible paths through space. When we ask whether light might take detours through the cosmos, we are in some ways echoing what quantum mechanics already tells us, that light does not travel in the simple, straightforward way our classical intuitions suggest. The journey of a photon from source to detector is a quantum event, a process governed by probabilities and superpositions rather than the deterministic paths we imagine when we think of a ball flying through the air. And yet, for most practical purposes, we can treat light as if it travels in straight lines at constant speed. This is because the quantum effects, the strange superpositions and multiple paths, tend to average out at large scales. When we are dealing with the light from a star millions of light years away, the quantum fuzziness is negligible compared to the vast distances involved. We can calculate when the light should arrive and where it should appear, and our predictions are confirmed by observation with remarkable precision. But here is where our gentle speculation for tonight begins to take shape. We have measured light travelling through the vacuum of space, and our measurements confirm that it moves at the expected speed and follows the expected paths. But what if our measurements only capture the light that took the direct route? What if there are other photons, also emitted from the same sources at the same times, that took different paths, quantum paths that led them through hidden dimensions or curved corridors of space-time, and that are still travelling toward us even now? This is not something we can easily test, because by definition, the light that has not yet arrived is not available for us to measure. We can only study the photons that have reached us, and those photons tell us a consistent story about the speed and behaviour of light. But absence of evidence is not evidence of absence, as scientists are fond of saying. The possibility remains that there is light travelling toward us that we have not yet received, light that took detours we did not anticipate, light that will arrive with slightly different messages about the same cosmic events. Let us pause here and take a breath. This is a contemplation, not an argument. I am not trying to convince you that light definitely takes detours through hidden dimensions. I am inviting you to hold this possibility gently, to feel its weight and texture, to let it sit beside the scientific knowledge we have accumulated and see how they might coexist. Science gives us extraordinary power to predict and understand, but it also reminds us again and again that the universe is larger and stranger than our current theories can contain. Every major revolution in physics has come from recognizing that what we thought we knew was incomplete, that there were phenomena and patterns we had not yet accounted for. The history of our understanding of light is itself a story of such revolutions. We thought light was instantaneous until Römer showed it had a finite speed. We thought it was either a wave or a particle until quantum mechanics showed it was something stranger than either. We thought space was a simple stage on which light travelled until Einstein showed that space and time were woven together into a fabric that could curve and bend. At each step, the universe surprised us. At each step, we had to expand our concepts to accommodate a more complex and beautiful reality than we had imagined. So when we wonder tonight about whether light might take detours through the cosmos, we are wondering in the spirit of that scientific tradition. We are not rejecting what we know. We are asking whether there might be more than we know. We are not claiming certainty, we are cultivating curiosity, and we are allowing ourselves in the quiet darkness of this night to entertain possibilities that might be true or might simply be beautiful to contemplate. Consider what we have learned about space itself. Einstein's general theory of relativity, developed in the early 20th century, showed that space and time are not separate things, but aspects of a single unified fabric called spacetime. This fabric is not rigid and fixed. It can be curved and stretched by the presence of mass and energy. The Earth curves spacetime around itself, which is why things fall toward its surface. The Sun curves spacetime more strongly, holding the planets in their orbits not through some mysterious action at a distance, but by shaping the very geometry of the space through which they move. Light follows the curves of spacetime. This is not a metaphor, it is literal. When light passes near a massive object, its path is bent. We have observed this bending many times, most famously during solar eclipses when the positions of stars near the Sun appear slightly shifted because their light has curved around the Sun's mass on its way to Earth. We have also observed gravitational lensing on a cosmic scale, where the gravity of entire galaxies or clusters of galaxies bends the light from more distant objects behind them, sometimes creating multiple images or distorted arcs of the same background source. So light already does not travel in straight lines in the simplest sense. It follows the contours of space-time, and those contours can be quite complex. Near a black hole, space-time is so strongly curved that light can orbit the black hole multiple times before either falling in or escaping to infinity. In such extreme environments, the path of light can be stretched and twisted in ways that would be completely counterintuitive to someone who thought of space as flat and empty. But the geometry of space-time might be even more complex than general relativity alone suggests. Many physicists believe that our universe has more than the 4 dimensions we perceive, 3 of space and 1 of time. String theory, one of the leading candidates for a unified theory of physics, requires the existence of extra dimensions, typically curled up so small that we cannot directly detect them with current instruments. If these extra dimensions exist, they could provide pathways for light that we have not yet imagined, routes through higher dimensional space that would appear as detours from our four-dimensional perspective. This is speculative, of course. We do not have direct evidence that these extra dimensions exist, let alone that light travels through them, but it is a possibility that serious physicists consider, and it suggests that the universe might have hidden architecture that we have not yet discovered. If light can follow the curves of spacetime in 4 dimensions, why not the curves of higher dimensional space as well? If there are tunnels and folds in the fabric of reality that we cannot see, might some photons be wandering through them, taking longer paths to their destinations? And there are other speculative ideas as well. Some physicists have proposed that the vacuum of space is not truly empty, but filled with a seething quantum foam of virtual particles popping in and out of existence. This foam might interact with light in subtle ways, slowing it down or deflecting it slightly from its expected path. Others have proposed that dark matter and dark energy, the mysterious substances that make up most of the universe but that we cannot directly see, might affect the propagation of light in ways we have not yet understood. Still others have suggested that the constants of physics, including the speed of light, might vary slightly from place to place in the universe, creating regions where light travels faster or slower than we expect. None of these ideas are proven. Many of them might turn out to be wrong, but they remind us that our current understanding, as powerful and precise as it is almost certainly incomplete. The universe has more to teach us. There are phenomena out there that we have not yet detected, patterns we have not yet recognized, mysteries we have not yet begun to investigate, and somewhere in all that unknown territory there might be aspects of light's journey through space that would surprise us if we knew about them. This is the spirit in which I invite you to contemplate the possibility of wandering light tonight, not as a certainty, but as a wonder, not as a claim, but as a question. What if the photons reaching your eyes have taken paths you cannot imagine? What if the light from the stars has stories to tell that we do not yet know how to hear? What if reality is even more layered and complex than our best theories suggest, and the light streaming through the cosmos is exploring that complexity in ways we have not yet discovered? As you rest there, breathing slowly, letting your body grow heavier and your mind quieter, consider how remarkable it is that we have learned as much as we have about light. From the first recognition that it travels at a finite speed to the discovery of its quantum nature, to the understanding that it follows the curves of spacetime, each step has been hard-won, the result of centuries of careful observation and brilliant insight. We stand on the shoulders of giants, as Newton said, and the view from those shoulders is extraordinary. But even from this elevated vantage point, we can see that the horizon extends far beyond our current position. There is so much more universe out there, so much more physics to discover, so many more questions to ask. The light reaching us from the most distant galaxies left its sources when the universe was young, when the first stars were just beginning to ignite. We're still learning to read the messages that light carries, still developing instruments that can detect fainter and fainter photons, still building theories that can account for more and more of what we observe. And perhaps, as we continue this journey of discovery, we will find that light has secrets we did not anticipate. Perhaps we will discover new dimensions of space or new structures in the vacuum or new interactions between light and dark matter. Perhaps we will find evidence that some photons took longer paths to reach us, that the arrival time of light is more complex than a simple calculation of distance divided by speed. Or perhaps we will find that our current understanding is essentially correct, that light travels through space in the straightforward way we expect, and that the mysteries lie elsewhere. Either way, the wondering is worthwhile. Either way, the contemplation brings us closer to the universe and to ourselves. When we ask questions about light, we're asking questions about the most fundamental aspects of reality. We're asking about the nature of space and time, the structure of the cosmos, the connection between what we see and what is really there. These are questions that have occupied human minds for millennia, and they will continue to occupy minds for millennia to come. And so tonight, as you drift towards sleep, let yourself be part of that ancient and ongoing conversation. Let yourself wonder about light and its mysteries. Let yourself feel the connection between your small and specific existence and the vast cosmic drama of photons streaming across the universe. You're made of atoms that were forged in the hearts of stars. The light reaching your eyes has travelled for years or centuries or millennia to find you. You are part of the cosmos that you are contemplating, and the cosmos is contemplating itself through you. This is the gift of consciousness, the strange loop at the heart of existence. Matter has organized itself in such a way that it can ask questions about matter. Energy has configured itself in such a way that it can wonder about energy. And light, that most fundamental of cosmic messengers, is being received by a being who can think about what it means for light to travel, to arrive, to carry information across the vastness of space. Rest in this wonder. Let it carry you gently towards sleep. The questions will still be here in the morning, and the universe will still be full of mysteries waiting to be explored. But for now, it is enough to simply wonder, to hold the possibilities lightly, to feel the peaceful curiosity that comes from contemplating the nature of light. The stars are shining, the photons are travelling, and you are here, receiving their light, wondering about their journey, letting the ancient messages from across the cosmos wash over you as you prepare to dream. What a strange and beautiful thing it is, to be a creature of light in a universe of light. What a privilege it is, to live in an age when we understand so much about the nature of light, and yet still have so much more to discover. What a gift it is, to spend this quiet night contemplating the wandering paths that photons might take through the complex geometry of space-time. Let these thoughts be your companions as you continue to rest. Let them settle into your mind at whatever depth feels comfortable, and let yourself drift, slowly and peacefully, toward the sleep that awaits you. We have explored what we think we know about light, and we have glimpsed the edges of what we do not yet know. In the next movement of our journey, we will go deeper into the hidden geometry of space-time, the strange and beautiful architecture that shapes the paths of everything that moves through the cosmos. But that exploration will wait until you are ready. For now, simply breathe, simply rest, simply let the wonder be. The light is travelling. It has always been travelling. And somewhere out there, in the vast and quiet darkness between the stars, there might be photons wandering through hidden dimensions, following curved paths through the complex fabric of reality, carrying messages that we have not yet received. Perhaps, maybe, it's possible. These are the words that keep the mystery alive. These are the words that invite us to continue wondering, to continue exploring, to continue asking questions about the nature of light and the cosmos that generates it. And these are the words that can carry you gently into sleep, wrapped in the peaceful uncertainty of a universe that is far larger and stranger than we can imagine. Rest now. The light is with you. The stars are shining, and the cosmos is full of wonders waiting to be discovered. The contemplation continues, but there is no hurry. The universe has been here for billions of years, and will be here for billions more. The photons are patient messengers, travelling at their constant speed through the vast emptiness of space, carrying their information toward destinations they cannot know. And you are patient too, allowing these ideas to wash over you at their own pace, taking whatever meaning and wonder you can from them, letting the rest drift away like clouds across a summer sky. This is enough for now. This is more than enough. The questions are planted, the seeds of wonder are sown, and they will continue to grow in your mind even as you sleep. Tomorrow, or the next day, or sometime in the future, you might find yourself looking up at the stars and wondering about the paths the light has taken to reach you. You might find yourself thinking about quantum mechanics and photon superpositions and the curving of space-time around massive objects. You might find yourself holding gently the possibility that the universe is even more mysterious than you imagined and feeling peace rather than fear at that thought. And that will be enough. That will be more than enough. Because the wondering is the point, the curiosity is the gift, and the connection to the cosmos, the sense of being part of something vast and beautiful and endlessly surprising, is the reward for all those nights spent contemplating the mysteries of light. Sleep well, wanderer. Dream of photons and stars and the hidden geometry of space-time, and know that when you wake, the universe will still be here, still full of light, still waiting for you to wonder about its secrets. The journey continues. The light is travelling, and you are part of it all. There is a story that has been told about the universe, a story that seemed complete for more than 2 centuries before it was revealed to be only the beginning. It is the story of gravity as Isaac Newton understood it, a force that reached across the emptiness of space to pull objects toward each other, a mysterious action at a distance that could be precisely calculated but never truly explained. Newton himself was uncomfortable with this aspect of his theory. How could the sun reach out across millions of miles of empty space to hold the Earth in its orbit? How could gravity act without any visible connection, any medium, any mechanism? Newton did not know, and he admitted as much. He gave us the mathematics that perfectly predicted the motion of planets and moons and falling apples, but the question of how gravity actually worked remained unanswered, and so it stayed for 200 years, until a young physicist named Albert Einstein, working as a patent clerk in Switzerland, began to think about gravity in a completely new way. What emerged from his contemplation was a vision of the universe so strange and beautiful that it still takes our breath away more than a century later. Einstein showed that gravity is not a force at all, not in the way Newton imagined it. Gravity is geometry. Gravity is the shape of space-time itself. This is where our journey tonight takes us, into the hidden geometry that underlies everything we see, the curved and folded fabric of reality that shapes the paths of planets and stars and light. Because if we want to understand how light might take detours through the cosmos, we must first understand that space itself is not the simple, empty stage that our everyday intuitions suggest. Space is dynamic, space is curved, and the curves of space are where the mysteries begin. Let us start with something simple. Imagine a flat sheet of rubber, stretched taut and held at the edges. If you place a marble at one end of the sheet and flick it, the marble will roll in a straight line toward the other end. This is how we usually think of space, flat and empty, allowing objects to move along straight paths unless some force interferes. But now imagine placing a heavy bowling ball in the center of the rubber sheet. The sheet will sag downward around the ball, creating a dip, a valley, a curvature in the surface. Now if you flick the marble, it will not travel in a straight line. It will curve toward the bowling ball, following the contour of the sagging sheet. It might even orbit the bowling ball, going around and around the dip like a planet orbiting a star. This is Einstein's insight translated into a simple image. Massive objects do not reach out and pull on other objects. Instead, they warp the fabric of space-time around themselves, creating curves and dips that other objects naturally follow. The moon does not orbit the Earth because the Earth is pulling on it. The moon orbits the Earth because the Earth has curved space-time around itself, and the moon is following the curved path through that geometry. It feels like a force from our perspective, but at a deeper level it is simply objects moving along the straightest possible paths through a curved space. But space is not a two-dimensional rubber sheet. It is a four-dimensional fabric that includes time, as well as the three dimensions of space. This is why we call it space-time. And the curvature is not something we can easily visualize, because our minds evolved to navigate a three-dimensional world and struggle to picture anything more complex. But the mathematics works. Einstein's equations of general relativity describe exactly how mass and energy curve space-time, and the predictions of these equations have been confirmed by countless experiments and observations. Light too follows the curves of space-time. This is one of the most remarkable predictions of general relativity, and it was confirmed in a famous observation during a solar eclipse in 1919. The astronomer Arthur Eddington measured the positions of stars that appeared near the Sun during the eclipse, when the Sun's light was blocked and the stars could be seen. He found that their positions were slightly shifted from where they should have been, exactly as Einstein's theory predicted. The light from those stars had curved around the Sun's mass, following the dip in space-time that the Sun creates. Light, even though it has no mass of its own, is not immune to gravity. It follows the geometry of space-time just as planets and moons do. And so when we look at the universe, we are looking through a curved lens. The space between us and distant objects is not flat and empty. It is shaped by all the mass and energy it contains. Galaxies create dips. Black holes create abysses. The cosmic web of dark matter creates a subtle texture of curves and valleys across the whole of space. Light travelling through this curved geometry follows paths that bend and twist, taking routes that are not straight by our everyday standards, but are the natural path through the curved fabric of reality. This is already a form of detour, a way in which light's journey is more complex than a simple straight line through empty space. The light from a distant galaxy might bend around an intervening cluster, might split into multiple images, might be magnified or distorted by the gravitational lensing effect. We see this happening all the time in astronomical observations. Some of the most beautiful images from the Hubble and James Webb Space Telescopes show galaxies stretched into arcs and rings by the gravity of clusters in the foreground. These are not rare or exotic phenomena. They are glimpses of the curved geometry that shapes everything. But there might be even deeper curves in space-time than those created by ordinary matter and energy. This is where we enter the realm of speculation, the territory of possibilities that science has not yet confirmed, but has also not ruled out. What if the fabric of space-time has hidden folds, secret tunnels, extra dimensions that we cannot perceive with our senses or detect with our current instruments? What if light can travel through these hidden pathways, taking routes that are invisible to us, arriving at destinations by means we do not understand? The idea of extra dimensions is not as fanciful as it might sound. Some of the most promising theories in modern physics require their existence. String theory, which attempts to unify all the forces of nature and explain the fundamental nature of matter, requires the universe to have 10 or 11 dimensions, not the 4 we perceive. Most of these extra dimensions are thought to be curled up very small, so tiny that we cannot directly detect them. But they might still affect the behaviour of particles and light in subtle ways. Imagine an ant walking along a thin wire. From the ant's perspective, the wire is essentially one-dimensional. The ant can walk forward or backward, but it cannot easily perceive or explore the tiny dimension of the wire's thickness. If the wire had a small loop or coil, the ant might walk past it without even noticing. But a smaller creature, one capable of perceiving the wire's full thickness, might explore that hidden dimension and find pathways that the ant could never imagine. Similarly, we might be like the ant, perceiving only the large dimensions of space and time, while remaining unaware of tiny extra dimensions that are curled up at scales too small for us to see. Light, or at least some forms of light, might be able to access these hidden dimensions, to take shortcuts or detours through the compact extra spaces to arrive at destinations by routes that we, trapped in our 4-dimensional perception, cannot detect. This is speculative, I want to emphasize again. We do not have evidence that light travels through extra dimensions, but the possibility is intriguing, and it has been explored by serious physicists who are trying to understand the deep structure of reality. If extra dimensions exist, they would add new layers to the geometry of space-time, new curves and pathways that could affect how light propagates across the cosmos. And there are other possibilities as well. General relativity allows for strange configurations of space-time that might exist in the universe. Wormholes, for example, are hypothetical tunnels through space-time that could connect distant points in the universe. If you could travel through a wormhole, you could take a shortcut, arriving at a destination without having to traverse all the space between. Could light travel through wormholes? The physics is uncertain. Wormholes, if they exist, might be too unstable to allow anything to pass through them, or they might be stabilized by exotic forms of matter that we have not yet discovered. We simply do not know. But even without wormholes or extra dimensions, the ordinary curvature of space-time creates possibilities for light to take longer or shorter paths, depending on the geometry it encounters. Light travelling through regions of high curvature moves through more complex geometry, and might take longer to reach us than light travelling through flatter regions. The time delay caused by gravitational lensing is a real effect that astronomers have measured. When a supernova explodes in a distant galaxy and its light is lensed by an intervening galaxy, we sometimes see multiple images of the same explosion, arriving at different times because the light took different paths around the lens. So in a very real sense, light already takes detours through space. It already arrives at different times depending on the path it has taken through the curved fabric of space-time. The universe is already more complex than a simple collection of sources sending light in straight lines to detectors. The geometry matters. The curves matter. And we are only beginning to understand all the ways in which this geometry shapes what we see. Tonight, as you rest in the quiet darkness, I invite you to imagine the hidden geometry of the cosmos. Imagine space-time not as an empty stage but as a living fabric, curved and folded by everything it contains. Imagine galaxies sitting in the dips they create, stars warping the space around them, black holes creating abysses from which not even light can escape. Imagine light travelling through this landscape, following the contours, bending around obstacles, taking the natural paths that the geometry provides, and then imagine that there might be more to this geometry than we have yet discovered. Hidden dimensions, curled up small but still present. secret tunnels connecting distant points through pathways we cannot see, subtle structures in the vacuum affecting the propagation of light in ways we have not yet measured. The universe is almost certainly more complex than our current understanding, and the geometry of space-time is one of the places where that complexity might be hiding. I find something deeply peaceful in this contemplation. It reminds me that we live in a universe of layers, that reality has depths we have not yet plumbed, that the cosmos is generous with its mysteries. We are not at the end of discovery, we are still very much in the middle, perhaps even at the beginning. There is so much more to learn, so many more curves and folds to explore, so many more surprises waiting in the hidden geometry of space-time. And yet, even in our incompleteness, we can wonder. We can lie here in the darkness and imagine the paths that light might take through the cosmos. We can feel the curvature of space-time as a gentle reality, not threatening but beautiful, not confusing but inviting. The universe is shaped by mass and energy, and we are part of that shaping. Our own bodies, tiny as they are on cosmic scales, create infinitesimal dips in space-time. We are contributors to the geometry, even as we are shaped by it. Light travelling past Earth is very slightly bent by our planet's gravity. Light travelling past you is even more slightly bent by the mass of your body. These effects are far too small to measure, but they are real. You're part of the cosmic geometry. You're shaping space-time even as space-time shapes the light that reaches your eyes. This is the interconnection that general relativity reveals. Everything affects everything else. Mass curves space-time, and curved space-time affects how mass moves. Light follows the curves, and the curves are shaped by the distribution of matter and energy throughout the universe. It is a dynamic relationship, constantly evolving, endlessly complex. And we are woven into it, participants in the cosmic dance, not spectators standing outside. Let yourself drift into this vision. Let yourself imagine floating in the curved geometry of space-time, surrounded by the subtle dips and valleys created by distant stars and galaxies. Imagine light streaming past you, following paths you cannot see, bending around invisible curves, arriving from sources billions of light-years away. You're at the center of your own observable universe, receiving light from all directions, gathering messages from across the vastness of space. And somewhere in all that light, there might be photons that took the long way around. Photons that encountered unusual curvature, that slipped through hidden dimensions, that wandered through the complex geometry of space-time before finally arriving at your eyes. If this is true, then the universe is even more layered than we imagined. The same event might send light to us along multiple paths, each one arriving at a different time, each one carrying a slightly different perspective on the same cosmic moment. This is not something we can easily test, but it is something we can contemplate. It is something we can hold gently in our minds as we drift towards sleep. The geometry of space-time is strange and beautiful, and it might be stranger and more beautiful than we have yet discovered. The light reaching us might carry secrets we have not yet learned to read, messages encoded in arrival times and path lengths and subtle patterns that await future generations of astronomers to decode. For now, we rest in the wonder. For now, we let the hidden geometry be a source of peaceful curiosity rather than anxious uncertainty. The universe is large, and we are small, but our smallness does not make us insignificant. We are part of the geometry. We are recipients of the light. We are conscious beings capable of wondering about the nature of space-time itself, a capacity that is, in its own way, as remarkable as any cosmic phenomenon. The curves of space-time hold the planets in their orbits and bend the light from distant stars. They might also contain pathways we have not yet discovered, dimensions we have not yet detected, structures we have not yet imagined. And somewhere in all that hidden geometry, light is travelling, following the paths that space-time provides, carrying its messages across the vastness of the cosmos. Perhaps some of those messages are taking detours. Perhaps some of them are still on their way, wandering through the curves and folds of reality, delayed by the complexity of the geometry they are traversing. If so, there might be light arriving at your eyes tonight that set out from its source at the same moment as light that arrived years ago, or centuries ago, or millennia ago. The same star, the same event, might be sending us messages along multiple paths, each one taking a different route through the hidden architecture of space-time. This is the possibility that we are contemplating tonight, not as a certainty, but as a wonder. not as a fact, but as a question. The geometry of space-time is strange and beautiful, and it might be stranger and more beautiful than we have yet discovered, and that, I think, is something to rest peacefully with, something to carry into sleep as a companion rather than a concern. The stars are shining, the photons are travelling, and somewhere in the vast and quiet darkness between them, the geometry of space-time is curved and folded in ways we are only beginning to understand. Let yourself be held by this geometry. Let yourself feel the gentle curves that connect you to everything else in the universe. Let yourself imagine the paths of light bending around stars and galaxies, following the contours of space-time, arriving at your eyes after journeys so long and complex that they beggar imagination. You are a destination. You are a receiver. You are part of the cosmic story that light is telling, and as you drift towards sleep, as your breathing grows slower and your thoughts grow quieter, let the hidden geometry of space-time be a source of peaceful wonder. The universe is vast and mysterious, and the mysteries are beautiful. The curvature of space holds the cosmos together, and you are part of what it holds. The light is travelling, and it is travelling toward you. Rest now. The geometry is gentle, the curves are kind, and the light, wherever it wanders, is always making its way toward eyes that might wonder about its journey. The contemplation continues, but there is no need to follow every thought to its conclusion. Let the ideas drift, let them settle, let them become part of the quiet background of this night. The hidden geometry of space-time is there, whether we think about it or not. It is shaping everything, bending every beam of light, holding every planet in its orbit. And it will still be there in the morning, still full of mysteries, still waiting for us to wonder about its nature. For now, sleep is approaching. For now, the journey through the wandering light pauses to let you rest. But the light continues travelling, the photons continue streaming, and the geometry of space-time continues its quiet work of shaping the cosmos. You are part of it all. You have always been part of it. And in the morning when you wake, the universe will still be here, curved and beautiful and full of wonders waiting to be explored. The story of light and its detours through space is far from over. We have barely begun to explore the possibilities, barely scratched the surface of what the hidden geometry might contain. But that exploration will wait. The questions are patient and the cosmos is in no hurry. For billions of years, light has been travelling through the curved fabric of space-time, and for billions more it will continue. And you are here in this moment receiving some of that light, wondering about its journey, preparing to dream about the mysteries of the cosmos. Sleep well, wanderer. The geometry holds you gently, the light is always travelling, and the universe, in all its curved and folded beauty, is full of wonders we have not yet imagined. Let the darkness be soft around you, let the quiet be peaceful, and let the hidden curves of space-time carry you gently toward rest, toward dreams, toward whatever visions the sleeping mind might offer of light and space and the endless mystery of existence. The journey continues, but you can rest now. The light will still be there when you return. The questions will still be waiting, and the cosmos, in all its vastness, will still be inviting you to wonder about the paths that photons take through the strange and beautiful geometry of space-time. Rest, breathe, and let the wonder carry you into sleep. The next chapter of our journey will explore the theoretical possibilities in more depth, the ideas that physicists have proposed about how light might wander through hidden dimensions and cosmic detours. But that exploration waits for another moment, another breath, another movement of the gentle contemplation we are sharing. For now, this is where we pause. This is where we let the ideas settle, and the body rest, and the mind grow quiet. The light is travelling, always travelling, through the curved and folded geometry of space-time. And you are here, receiving it, wondering about it, part of the same cosmos that sends and receives the endless stream of photons. Sleep now. The universe is patient, and the mysteries will keep until you're ready to wonder about them again. In the quietness of this moment, as you settle deeper into the comfortable darkness that surrounds you, let us venture further into the realm of possibilities. We have travelled through the nature of light and the hidden geometry of space-time, and now we arrive at a threshold where established science meets the gentle mist of speculation. This is not a place to fear, but a place to wonder. Here, at the edge of what we know, the universe invites us to imagine what might be true, to hold possibilities lightly in our minds, to feel the exhilaration of contemplating ideas that have not yet been proven, but that shimmer with the potential of discovery. What if the cosmos contains pathways that we cannot see? What if the fabric of reality is folded in ways that create hidden corridors, secret routes through which light might wander before reaching our eyes? These are the questions that theoretical physicists have explored with mathematics and imagination, proposing frameworks that could, if true, transform our understanding of how light travels across the vastness of space. Tonight we will explore some of these possibilities together, not to convince you of their truth, but to invite you into the wonder of contemplating what the universe might contain. Let us begin with the idea of extra dimensions, a concept that sounds like science fiction, but that emerges naturally from some of our most sophisticated theories of physics. We experience the world in 4 dimensions, 3 of space, allowing us to move forward and backward, left and right, up and down, and 1 of time, carrying us inexorably from past through present toward future. These are the dimensions we can perceive, the framework within which our entire experience of reality unfolds. But what if there are more dimensions than these? What if the universe has hidden depths that we cannot directly access, but that nonetheless affect the behavior of light and matter? This possibility arises most prominently in string theory, one of the leading candidates for a unified theory of physics. String theory proposes that the fundamental constituents of reality are not point-like particles but tiny vibrating strings of energy. The different ways these strings can vibrate correspond to different particles with different properties, much as the different ways a guitar string can vibrate produce different musical notes. But for the mathematics of string theory to work consistently, the strings must vibrate in a space with more than 4 dimensions. Depending on the version of the theory, the universe might have 10, 11, or even more dimensions. Where are these extra dimensions? Why do we not perceive them? The most common answer is that they are compactified, curled up so small that we cannot detect them with our senses or our current instruments. Imagine a garden hose viewed from a great distance. From far away, it looks like a one-dimensional line. But if you could get close enough, you would see that it has another dimension, the circular dimension around its circumference. At every point along the hose, there is a tiny circle that you could walk around if you were small enough. The extra dimensions of string theory might be like this, present at every point in space but curled up at scales far smaller than atoms, far smaller than anything we can currently probe. Now, what does this have to do with light taking detours through space? Here is where the speculation becomes truly fascinating. If extra dimensions exist, they might provide additional pathways for light to travel. A photon moving through our familiar 4-dimensional spacetime might, under certain conditions, also move through the compactified dimensions. This would add length to its journey, causing it to arrive later than a photon that took the straightforward 4-dimensional path. From our perspective, the 2 photons would have travelled the same apparent distance, but one would have taken a detour through dimensions we cannot see. This is not something that current physics predicts in detail. We do not have a well-developed theory of how light might interact with compactified dimensions, but the possibility exists within the mathematical framework of string theory, and it suggests that the journey of light across the cosmos might be more complex than our 4-dimensional intuitions would suggest. If some photons wander through extra dimensions while others do not, the light from a single cosmic event might arrive at our detectors at different times, carrying slightly different information about the same source. Consider what this would mean. A star explodes in a distant galaxy, a supernova that blazes briefly brighter than billions of ordinary stars. Light from that explosion streams out in all directions, photons carrying the signature of that violent event across the vastness of space. Most of those photons, we assume, travel through ordinary 4-dimensional spacetime, arriving at Earth after a journey of millions or billions of years depending on the distance. But what if some of those photons took detours through compactified dimensions? What if they are still travelling, still winding their way through the hidden depths of reality, carrying the same message but taking longer to deliver it? If this were true, we might eventually receive light from the same supernova again, arriving late because it took the scenic route through extra dimensions. We would see the same explosion twice, or perhaps many times, each arrival corresponding to a different path through the multi-dimensional landscape of reality. The universe would be even more layered than we imagined, with multiple versions of the same events reaching us at different times depending on the paths the light has taken. This is a beautiful speculation, and I want you to hold it gently as you rest there in the darkness. We do not know if it is true. We do not have evidence that light wanders through extra dimensions, but the possibility is consistent with our best theoretical frameworks, and it reminds us that the universe might contain wonders we have not yet discovered. The paths of light through space might be far more varied and complex than we have imagined, and the messages from distant stars might be arriving in waves, each wave taking a different route through the hidden geometry of reality. But extra dimensions are not the only theoretical possibility for how light might take detours through space. Let us consider another idea, one that has been proposed by various physicists over the decades: the concept of tired light. This is a hypothesis that has largely fallen out of favour in mainstream cosmology, but it illustrates how scientists have wondered about alternative explanations for cosmic phenomena, and it invites us to think about the many ways light's journey might be affected by its passage through space. The tired light hypothesis was proposed in the early 20th century as an alternative explanation for the redshift of distant galaxies. Astronomers had noticed that light from distant galaxies was shifted toward the red end of the spectrum, with more distant galaxies showing greater redshift. The mainstream explanation, which has been confirmed by countless observations, is that the universe is expanding, and the light is stretched as it travels through expanding space. But some scientists proposed an alternative. What if light loses energy as it travels through space, not because space is expanding, but because some process is draining the photons of their energy? This energy loss would also shift the light toward red, mimicking the effect of cosmic expansion. The tired light hypothesis has been largely ruled out by observations. The detailed patterns of cosmic microwave background radiation, the time dilation of distant supernovae, and many other phenomena strongly support the expanding universe model and are inconsistent with tired light. But the underlying question remains intriguing. Does light interact with the vacuum of space in ways that we do not fully understand? Could there be subtle processes that affect photons during their long journeys across the cosmos? Modern physics suggests that the vacuum of space is not truly empty. At the quantum level, the vacuum seethes with virtual particles that pop in and out of existence, borrowing energy from the uncertainty principle for the briefest of moments before returning it. This quantum vacuum might interact with light in subtle ways, affecting its propagation through space. Some physicists have proposed that the vacuum might act as a very slight medium, slowing light down by infinitesimal amounts, or causing it to scatter in ways we have not yet detected. If the vacuum affects light's journey, even slightly, it could contribute to the sense that some photons are taking longer to reach us than others, not through extra dimensions or wormholes, but through the subtle resistance of the quantum vacuum itself. Light might not travel through a perfect void, but through a gentle sea of quantum fluctuations, each interaction adding a tiny delay, each passage through the vacuum contributing to a journey that is slightly longer than we calculated. Again, this is speculative. We do not have evidence that the quantum vacuum significantly affects the travel time of light across cosmic distances. But the possibility exists at the edge of our understanding, a question mark hovering over our calculations of when light should arrive from distant sources. The vacuum might be more complex than we imagine, and light's passage through it might be affected in ways we have not yet measured. Let us consider yet another possibility, one that arises from the intersection of general relativity and quantum mechanics. These two pillars of modern physics have never been fully unified. General relativity describes gravity as the curvature of spacetime, while quantum mechanics describes the behaviour of particles at the smaller scales. Both theories work extraordinarily well within their domains, but they are fundamentally incompatible at the deepest level. Somewhere, in regimes we cannot yet access, these two frameworks must give way to a more complete theory that encompasses both. In the meantime, physicists have proposed various ideas about what this unified theory might look like, and some of these ideas have implications for how light travels through space. One proposal involves the idea of spacetime foam, a concept suggested by the physicist John Wheeler. At extremely small scales, far smaller than atoms or even subatomic particles, spacetime itself might become turbulent and chaotic, fluctuating wildly in a quantum froth of geometry. This foam would be invisible at our scales, smoothed out like the surface of the ocean, appears smooth from an airplane even though it is covered in waves at the human scale. If spacetime is foamy at the Planck scale, the smallest scale that physics can meaningfully describe, then photons travelling through this foam might be affected by the tiny fluctuations in geometry. Each passage through a bit of spacetime foam might add a minuscule delay, each quantum fluctuation in the geometry contributing to a journey that is imperceptibly but genuinely longer than it would be through perfectly smooth spacetime. Over cosmic distances, these tiny effects might accumulate, causing some photons to arrive later than expected. This is an idea that physicists have actually tried to test, looking for evidence that the quantum nature of spacetime affects the propagation of light from distant sources. So far, the results have been inconclusive. We have not found clear evidence that spacetime foam delays light in detectable ways, but we also have not definitively ruled it out. The quantum structure of spacetime remains one of the great mysteries of physics, and its effects on light are still being investigated. As you rest there, breathing slowly, letting your body grow heavier and your mind more peaceful, I want you to hold all these possibilities gently. Extra dimensions curled up at tiny scales, quantum vacuum fluctuations interacting with photons, spacetime foam adding delays to light's journey. These are not certainties, they are questions, explorations, invitations to wonder about the deep structure of reality. They remind us that the universe is far from fully understood, that the path of light from star to eye might be more complex than we have imagined, and there are still more possibilities to consider. Let us venture even further into the realm of speculation, into ideas that are less established but equally fascinating to contemplate. Some physicists have proposed that the constants of physics, including the speed of light, might not be truly constant. Instead, they might vary slightly from place to place in the universe, or even over time. If the speed of light were slightly different in different regions of space, then photons travelling through those regions would arrive at different times than we would calculate based on a constant speed. Some light might take longer to reach us not because it took a longer path, but because it travelled through regions where the speed limit was slightly lower. This is a controversial idea, and most physicists believe that the speed of light is indeed constant everywhere in the universe. But the possibility has been explored, and it reminds us that even our most fundamental assumptions might not be absolutely certain. The speed of light is one of the cornerstones of physics, appearing in countless equations and predictions. If it varied, the implications would be profound, rippling through our understanding of space and time and causality. And yet, we cannot completely rule out the possibility without more data, more observations, more exploration of the cosmos and its subtle variations. Another speculative possibility involves the nature of dark energy, the mysterious force that appears to be accelerating the expansion of the universe. We do not know what dark energy is. We know that it exists, that it makes up about 70% of the total energy content of the universe, and that it causes the expansion of space to speed up over time. But its fundamental nature remains a mystery, one of the biggest open questions in cosmology. If dark energy interacts with light in ways we do not understand, it could affect the travel time of photons across cosmic distances. Perhaps dark energy creates subtle variations in the properties of space, regions where light travels slightly faster or slower. Perhaps it adds a kind of cosmic resistance that affects the propagation of photons. We do not know, and until we understand dark energy better, we cannot rule out these possibilities. Similarly, dark matter, the invisible substance that makes up about 25% of the universe's mass, might affect light in ways we have not yet discovered. We know that dark matter interacts gravitationally, curving space-time around itself and bending the paths of light that pass nearby. But might it also interact with light in other ways? Might photons travelling through regions of high dark matter density experience subtle effects that alter their travel time or their path? These are questions that physicists continue to explore, and the answers might surprise us. All of these possibilities, from extra dimensions to quantum vacuum effects to variations in the speed of light, share a common thread. They suggest that the journey of light across the cosmos might be more complex and mysterious than our current understanding allows. They invite us to hold our knowledge humbly, to recognize that the universe almost certainly contains phenomena we have not yet discovered. And they offer, for those of us lying in the darkness and wondering about the nature of reality, a source of peaceful curiosity, a reminder that the cosmos is generous with its mysteries. Let us pause here and breathe. Let us allow these ideas to settle into our minds without demanding that we understand them fully or believe them completely. The beauty of contemplation is that it does not require certainty. We can hold possibilities lightly, turning them over in our minds like smooth stones found on a beach, appreciating their shapes and textures without needing to know their geological history. The universe might contain extra dimensions, or it might not. Light might wander through hidden pathways, or it might take the most direct route. Either way, the wandering is worthwhile, the contemplation is enriching, and the cosmos remains beautiful. As you drift deeper into relaxation, I want you to imagine a photon setting out from a distant star. This photon was born in the nuclear furnace at the star's core, created when hydrogen atoms fused into helium, releasing energy in the form of light. It began its journey toward the surface of the star, bouncing off atoms and electrons, gradually making its way through the dense stellar material until finally, after perhaps hundreds of thousands of years, it emerged into the vacuum of space. Now imagine that photon travelling through the cosmos, passing through the vast empty spaces between stars, traversing the dark voids between galaxies, streaming through the thin gas and dust that fills intergalactic space. It is following the straightest path it can through the curved geometry of spacetime, bending around massive objects, following the contours of the cosmic web, and then, perhaps, it encounters something else. Perhaps it slips through a fold in extra-dimensional space. Perhaps it interacts with the quantum vacuum in a way that adds a tiny delay to its journey. Perhaps it passes through a region where the speed of light is imperceptibly different from elsewhere. These are maybes, not certainties. But they are beautiful maybes, invitations to imagine a cosmos that is even richer and more complex than we have discovered. That photon, born in a distant star, is on a journey that we can only partially comprehend. And when it finally reaches Earth, when it enters your eye and triggers a cascade of signals in your retina, it carries with it the story of its journey. A story that might include chapters we have not yet learned to read. This is the wonder of theoretical physics, the joy of contemplating the deep structure of reality. We do not know everything. We have not solved all the mysteries, but we have learned enough to ask extraordinary questions, to imagine possibilities that would have been inconceivable to our ancestors, to feel the exhilaration of standing at the edge of knowledge and peering into the unknown. And so we continue, you and I, drifting through these ideas together. The night is long, and the cosmos is patient. The photons are streaming through space, some taking the direct route, some perhaps wandering through hidden pathways we cannot see. And we are here, receiving their light, wondering about their journey, part of the same universe that sends and receives these cosmic messages. Let us consider one more theoretical possibility before we move on to examine the evidence that astronomers have gathered. This is perhaps the most dramatic idea of all, though we will approach it with the same gentle curiosity we have brought to everything else tonight. It is the idea of wormholes, hypothetical tunnels through space-time that could connect distant points in the universe. Wormholes arise naturally from the mathematics of general relativity. Einstein's equations allow for configurations of space-time that include tunnels, bridges, connections between regions that are far apart in ordinary space. If you could travel through a wormhole, you could take a shortcut, arriving at a distant destination without having to traverse all the intervening space. This is the stuff of science fiction, the technology that allows spaceships to travel between stars in stories and movies. But it is also a genuine prediction of our best theory of gravity. The catch is that we do not know if wormholes actually exist in nature. The mathematics allows for them, but that does not mean the universe has created any. And even if wormholes exist, they might be too unstable to allow anything to pass through them. They might collapse before a traveller or a photon could make it from one end to the other. They might require exotic forms of matter with negative energy to hold them open, matter that might not exist anywhere in the universe. But let us imagine, just for the sake of peaceful contemplation, that wormholes do exist somewhere in the cosmos. Let us imagine that some of them are stable enough for light to pass through. What would this mean for photons travelling across the universe? If a wormhole connected a distant galaxy to our region of space, light from that galaxy might have two ways to reach us. It could travel through ordinary space, taking millions or billions of years to cross the intervening distance, or it could take the wormhole, arriving much sooner than expected. Alternatively, a wormhole might connect 2 points that are relatively close in ordinary space but require a long journey through the wormhole. Light taking this route would arrive later than expected, delayed by its detour through the wormhole tunnel. The possibilities are dizzying when we start to consider them. Wormholes could scramble our understanding of when and where events happened. Light from the same source could arrive at different times depending on whether it took the ordinary route or the wormhole route. The universe could be connected in ways we cannot see, with photons travelling through hidden tunnels, arriving at destinations that seem impossibly far away or impossibly close depending on the paths they have taken. This is highly speculative, even more so than the other ideas we have explored tonight. We have no evidence that wormholes exist, let alone that light travels through them. But the possibility is there, lurking in the mathematics of general relativity, reminding us that the cosmos might contain structures and pathways that we have not yet discovered. And perhaps that is the deepest lesson of all these theoretical possibilities. The universe is vast and our understanding is incomplete. We have learned an extraordinary amount about the nature of light and space and time, but there is so much more waiting to be discovered. The paths that photons take through the cosmos might be more varied and complex than we have imagined. The geometry of spacetime might contain folds and tunnels and dimensions that we cannot perceive. And the light reaching our eyes might carry secrets that we have not yet learned to decode. This is not a cause for frustration or despair. It is an invitation to wonder, a source of endless fascination. A reminder that the cosmos will continue to surprise us for as long as we are willing to keep asking questions. The theoretical possibilities we have explored tonight are not meant to be believed or disbelieved. They are meant to be contemplated, to be held gently in the mind, to be appreciated as examples of the kind of creative thinking that has driven physics forward for centuries. Tomorrow, or next year, or in a generation, some of these ideas might be confirmed by observation. Others might be ruled out. New possibilities might emerge that no one has yet imagined. This is how science works, a never-ending dance between theory and observation, speculation and evidence, imagination and reality. And we are privileged to be alive at a moment when so many profound questions remain open. When the edge of knowledge is still so close that we can almost touch it. Rest now in this wonder. Let the theoretical possibilities drift through your mind like clouds across a night sky. Extra dimensions, quantum vacuum effects, variations in the speed of light, wormholes connecting distant regions of space. These are the dreams of physics, the imaginings of minds that have dared to ask what the universe might contain beyond what we can see. And somewhere out there, in the vast and quiet darkness between the stars, the light is travelling. Some of it might be taking detours through hidden pathways. Some of it might be winding its way through compactified dimensions or quantum foam or tunnels through spacetime. We do not know. But the not knowing is part of the beauty. The mystery is part of the gift. You are here, receiving the light, wondering about its journey. You are part of the same cosmos that creates these mysteries and that might, someday, solve them. And for now, it is enough to simply wonder, to rest in the questions, to let the possibilities carry you gently towards sleep. The theoretical exploration continues in the hearts and minds of physicists around the world, working late in their offices and laboratories, scribbling equations on whiteboards, running simulations on computers, trying to understand the deep structure of reality. But you do not need to solve these problems tonight. You are allowed to simply enjoy the wondering, to appreciate the vastness of what we do not know, to feel the peaceful curiosity that comes from contemplating the mysteries of existence. The light is travelling, the theories are multiplying, and the universe, in all its complexity and beauty, is waiting to reveal its secrets to those patient enough to keep asking questions. Sleep is approaching, but the contemplation can continue in your dreams. Perhaps you will dream of photons wandering through extra dimensions. Perhaps you will imagine yourself travelling through a wormhole to a distant galaxy. Perhaps you will feel the gentle resistance of the quantum vacuum as you drift through the spaces between stars. These are the gifts of a mind that has been invited to wonder, a consciousness that has been open to the possibilities that physics reveals. Rest now. The night is long, and the cosmos is patient. The theoretical possibilities will still be there in the morning, waiting for you to wonder about them again. And the light, wherever it wanders, is always making its way toward eyes that might ask about its journey. We have explored the theoretical landscape, the ideas and speculations that physicists have proposed about how light might take detours through space. Now, in the next movement of our journey, we will turn to the evidence, the observations and measurements that astronomers have made at the edge of what we can detect. We will look for hints and clues that might support or challenge these theoretical possibilities, and we will find that the universe, as always, is more complex and mysterious than we expected. But that exploration will unfold in its own time. For now, simply breathe, simply rest, simply let the wonder be. The photons are travelling, the theories are waiting, and you are here, part of the same cosmos that generates both the light and the questions about its journey. There is a quiet kind of heroism in the work of astronomers, a patient dedication that spans careers and lifetimes and sometimes generations. They point their telescopes at the sky, gathering light that has travelled for millions or billions of years, photons that left their sources before Earth existed, before our sun ignited, before the galaxy we call home had settled into its current spiral shape. They count these photons, measure their properties, record their arrival times, and try to piece together the story of a universe so vast that the human mind can barely comprehend it. And sometimes, in the careful analysis of their data, they find anomalies, puzzles, mysteries that do not quite fit the theories we have developed. Tonight, let us turn our attention to these observations, these hints from the edges of what we can detect. We will explore what astronomers have seen and measured, what they have found puzzling or unexpected, and how these observations might relate to our gentle speculation about light taking detours through space. This is not a search for proof. We are unlikely to find definitive evidence that light wanders through hidden dimensions or extra-dimensional pathways, but we might find whispers, suggestions, possibilities that keep the wonder alive. Let us begin with the cosmic microwave background, the oldest light in the universe. This radiation fills all of space, a faint glow left over from a time when the universe was young and hot, when matter and energy were in a different state than they are today. About 380,000 years after the Big Bang, the universe cooled enough for atoms to form, and the light that had been scattering off free electrons was suddenly able to travel freely through space. That light has been travelling ever since, stretched by the expansion of the universe from the hot glow of the early cosmos to the cold microwave radiation we detect today. The cosmic microwave background is remarkably uniform. If you look in one direction and then the opposite direction, the temperature of this radiation is the same to about 1 part in 100,000. This uniformity is itself a mystery, one that cosmologists explain with the theory of inflation, a brief period of extremely rapid expansion in the first fraction of a second after the Big Bang. But within that uniformity, there are tiny fluctuations, slight variations in temperature from one part of the sky to another. These fluctuations are the seeds from which all the structure in the universe grew: galaxies, clusters, the cosmic web of matter that we see today. Astronomers have mapped the cosmic microwave background with exquisite precision, using satellites like COBE, WMAP, and Planck to measure its temperature across the entire sky. And in these maps, they have found some curious features that do not fit neatly into our standard cosmological models. There is a cold spot, a region of the sky where the temperature is slightly lower than expected. There are alignments between large-scale patterns that seem unlikely to occur by chance. There are asymmetries that suggest the universe might not be perfectly uniform in all directions. Now, these anomalies have mundane explanations. They might be statistical flukes, rare but not impossible outcomes of the random processes that generated the fluctuations. They might be artifacts of how we observe and analyze the data. They might be hints of new physics, but physics that is well within the framework of standard cosmology. None of these anomalies require us to invoke light-taking detours through extra dimensions or hidden pathways. But they remind us that the universe, even at the largest scales, contains features we do not fully understand. The cosmic microwave background is a snapshot of the universe as it was 13.8 billion years ago, and the light carrying that snapshot has been travelling toward us ever since. If some of that light took different paths, travelled through different geometries, arrived at slightly different times, it might contribute to the anomalies we observe. This is speculative, and there is no evidence that it's true, but it is a possibility that we can hold gently as we contemplate the journey of light across cosmic time. Let us turn now to a more recent observation, one that has sparked both excitement and controversy in the astronomical community. In the past few decades, astronomers have developed new ways to measure the expansion rate of the universe, a quantity known as the Hubble constant. This constant tells us how fast the universe is expanding today, how quickly distant galaxies are receding from us due to the stretching of space. There are two main methods for measuring the Hubble constant. One uses observations of the cosmic microwave background, extrapolating from the conditions of the early universe to predict what the expansion rate should be today. The other uses observations of nearby cosmic objects, particularly a type of exploding star called a type Ia supernova, to directly measure how fast galaxies are moving away from us. Both methods are sophisticated and have been refined over decades of careful work. The problem is that these two methods give different answers. The cosmic microwave background measurement suggests the Hubble constant is about 67 kilometers per second per megaparsec. The supernova measurements suggest it is about 73 kilometers per second per megaparsec. This discrepancy, known as the Hubble tension, has persisted as measurements have improved, and it now appears to be a real feature of the data rather than an experimental error. What could cause this tension? Many explanations have been proposed. Perhaps there is new physics that affects the expansion rate, some form of dark energy that has changed over time, or some new particle that influenced the early universe. Perhaps there are systematic errors in one or both measurement methods that we have not yet identified. Perhaps our understanding of the relationship between the early and late universe is incomplete. And here, at the edge of our understanding, we might wonder about light's journey. If light from distant supernovae took slightly different paths to reach us than we expect, if some of it was delayed by detours through hidden geometries, our measurements of their distances might be subtly affected. The Hubble tension might be telling us not just about the expansion of the universe, but about the complex paths that light takes through the cosmos. I want to be clear that this is not the mainstream explanation for the Hubble tension. Astronomers and cosmologists are exploring many possibilities, and the idea that light takes detours is not among the leading candidates. But the tension is real, the discrepancy is unexplained, and it reminds us that our measurements of the cosmos, however precise, depend on assumptions about how light travels from source to detector. If those assumptions are incomplete, our conclusions might be subtly wrong. As you rest there, breathing slowly, letting your body grow more relaxed, consider the delicate work of measuring the universe. Astronomers point their telescopes at objects billions of light years away, collecting photons that have travelled for billions of years, and from those faint signals they try to deduce the properties of the cosmos. It is an astonishing achievement, a testament to human ingenuity and dedication. But it is also humble work, constantly checking and rechecking assumptions, always open to the possibility that something has been missed. The Hubble tension might be resolved in the coming years. New observations might identify the source of the discrepancy. New theories might explain how the early and late universe are connected. Or the tension might persist, a stubborn mystery that points to something fundamental that we do not yet understand. Either way, it reminds us that the universe still has secrets, that the light reaching us from distant objects carries information we have not yet learned to decode. Let us consider another observation, one that directly involves the travel time of light across cosmic distances. When a massive star explodes as a supernova, it releases an enormous amount of energy, including light across the entire electromagnetic spectrum. If that supernova is lensed by an intervening galaxy, the gravity of the galaxy bends the light, creating multiple images of the same explosion. These images might take slightly different paths around the galaxy, arriving at Earth at different times. Astronomers have observed this phenomenon directly. In some cases, they have seen the same supernova appear multiple times, each image arriving weeks or months after the previous one, delayed by the different path it took through the curved spacetime around the lensing galaxy. This is a beautiful confirmation of general relativity, a direct demonstration that light follows the geometry of spacetime, and that different paths through that geometry lead to different travel times. But it also raises fascinating questions. If light can be delayed by gravitational lensing, if different photons from the same event can arrive at different times, depending on the paths they take, what else might affect the travel time of light? We understand gravitational lensing well. It is predicted by general relativity and confirmed by countless observations. But might there be other effects, subtler and harder to detect, that also cause variations in light's travel time? Some astronomers have looked for evidence of such effects, searching for patterns in the arrival times of light from distant sources that cannot be explained by gravitational lensing alone. So far, The evidence is inconclusive. The universe is noisy, filled with many processes that can affect the light we receive, and it is difficult to disentangle the effects of one process from another. But the search continues, and it is possible that future observations with more sensitive instruments and larger datasets might reveal something unexpected. The James Webb Space Telescope, launched in 2021, has opened a new window on the universe. Its infrared vision allows it to see objects that are invisible to telescopes working at other wavelengths, and its sensitivity allows it to detect the faintest and most distant sources. Already it has produced images of staggering beauty and scientific value, revealing galaxies that formed when the universe was young, capturing the light that has travelled for billions of years to reach us. Among the early discoveries of the James Webb Space Telescope are galaxies that appear surprisingly mature for their age. According to our understanding of cosmic history, galaxies in the early universe should be small, irregular, still in the process of forming. But some of the galaxies that James Webb has observed appear fully formed, with structures that we would expect to see only in older galaxies. This has prompted astronomers to reconsider their models of galaxy formation, to ask whether galaxies formed faster than we thought, or whether something else is going on. Could light from these galaxies be arriving later than expected, carried by photons that took detours through the cosmos? This is a speculative suggestion, and it is not the explanation that astronomers are pursuing. The more likely answer is that our models of galaxy formation need refinement, that we have underestimated how quickly the first galaxies could grow. But the observation reminds us that the early universe is full of surprises, and that the light reaching us from those distant epochs might carry information we have not yet learned to interpret. As we continue our journey through the evidence, let us also consider the phenomenon of gamma-ray bursts, the most energetic explosions in the universe. These bursts are detected several times per day, flashes of gamma radiation that outshine entire galaxies for brief moments. They are thought to result from the collapse of massive stars or the merger of compact objects like neutron stars, and the light they produce travels across billions of light years to reach our detectors on Earth and in orbit. Gamma-ray bursts have been used to test the structure of spacetime at the smallest scales. If spacetime is foamy at the Planck scale, as some theories suggest, then photons of different energies might travel at slightly different speeds, with higher energy photons being more affected by the quantum fluctuations in the geometry. This would cause the different colours of light from a gamma-ray burst to arrive at different times, spread out by their journey through the quantum foam. Astronomers have looked for this effect, analysing the arrival times of gamma rays of different energies from the most distant bursts. So far the results have been largely consistent, with no dispersion, no spreading of arrival times based on energy. This places limits on how foamy spacetime can be, constraining the theories that predict such effects. But the limits are not absolute. The quantum structure of spacetime might affect light in ways too subtle for current observations to detect. Future gamma-ray observatories, with greater sensitivity and better timing resolution, might reveal effects that are currently hidden. There is something humbling about this work, about the attempt to use light from explosions billions of light years away to probe the quantum structure of spacetime. The distances involved are unimaginable. The energies are beyond anything we can create on Earth. And yet, with careful observation and clever analysis, astronomers can use this light to test the deepest theories of physics, to search for clues about the nature of space and time at the smallest scales. And at the edge of these observations, where the data grows sparse and the uncertainties grow large, there is room for wonder. We have not found definitive evidence that light takes detours through hidden dimensions or quantum foam. But we have not ruled it out either. The universe is vast and our observations are limited. The light reaching us from distant sources has travelled for billions of years, through regions of space we have never explored, along paths we can only partially reconstruct. Somewhere in that journey there might be effects we have not yet discovered. Let us also consider the observations of time itself, the strange dilation of time that occurs when light travels through a universe that is changing. When we observe a distant supernova, we are not just seeing an explosion that happened long ago, we are also seeing it in slow motion. The universe has expanded since the light was emitted, and this expansion has stretched not just the wavelength of the light, but also the time between events. A supernova that took 2 weeks to brighten and fade when it happened appears to take longer when we observe it, stretched by the expansion of the universe. This time, dilation is a prediction of standard cosmology, and it has been confirmed by observations. Distant supernovae do appear to evolve more slowly than nearby ones, exactly as predicted. This is strong evidence that the universe is expanding and that our understanding of cosmic evolution is correct. But it also raises interesting questions about the nature of time itself. If the expansion of the universe can stretch time, what else might affect the flow of time for light travelling across cosmic distances? We know that gravity slows time, that clocks in strong gravitational fields tick more slowly than clocks in weaker fields. This is another prediction of general relativity, confirmed by experiments with atomic clocks on airplanes and satellites. Might there be other effects, other influences on the flow of time that affect the light we receive from distant objects? These are questions at the edge of our understanding, invitations to wonder about the deep structure of time and its relationship to light's journey through the cosmos. We do not have answers tonight, but we have the questions, and the questions are themselves a kind of gift. They remind us that the universe is more complex than we can fully comprehend, that the light reaching our eyes has passed through regions of space and time that we have never directly experienced, that the messages from distant stars might carry more information than we currently know how to read. As you lie there, growing more relaxed, letting the thoughts drift through your mind without attachment, consider all the photons that are reaching you right now. Some have travelled only a short distance, from the lamp across the room or the screen in your hands. Some have travelled farther, from the stars outside your window. And some, if you were observing with a telescope, would have travelled for billions of years, crossing the vast emptiness of intergalactic space, bending around galaxies, passing through regions of dark matter and dark energy, arriving at your detector with information about events that happened when the universe was young. Each of those photons has a story. Each has taken a path through the cosmos that we can only partially reconstruct, and each carries, encoded in its wavelength and its arrival time and its polarization, information about everything it has encountered on its journey. We have learned to decode some of that information, to read the stories that photons tell about the temperature and composition and motion of the sources that emitted them. But there might be more stories waiting, more information encoded in ways we have not yet learned to access. Perhaps some photons have taken detours through extra dimensions, carrying with them the signature of geometries we cannot directly perceive. Perhaps some have wandered through quantum foam, their journey subtly affected by the fluctuations of spacetime at the smallest scales. Perhaps some have passed through regions where the constants of physics are slightly different, where the speed of light is not quite what we expect, where the rules that govern the cosmos have local variations we have not yet detected. These are maybes, not certainties. They are possibilities, not facts. But they are possibilities that the evidence has not ruled out, possibilities that live at the edge of our observations, in the gaps between what we have measured and what there is to measure. And holding them gently, as we have been doing throughout this contemplation, we can feel the vastness of the unknown stretching out before us, inviting us to wonder, inviting us to keep asking questions. The evidence from the edges of observation is not conclusive. It does not prove that light takes detours through the cosmos. But it also does not disprove it. The universe is vast and complex, and our understanding is incomplete. The anomalies in the cosmic microwave background, the tension in the Hubble constant, the surprisingly mature galaxies in the early universe, the limits on space-time foam, all of these are pieces of a puzzle that we are still assembling. And somewhere in that puzzle, there might be room for phenomena we have not yet imagined. This is the nature of science at the frontier. We do not have all the answers. We are still asking the questions, still gathering the data, still testing the theories. And the light from the cosmos is our primary source of information, the medium through which the universe communicates with us. Every photon that reaches our detectors is a messenger, carrying news from a distant source. And every anomaly, every unexpected observation is an invitation to look more closely, to think more deeply, to wonder what we might be missing. Rest now in this wonder. Let the evidence settle into your mind alongside the theories, two sides of the same cosmic coin. The universe is speaking to us through the light it sends, and we are learning, slowly and patiently, to understand what it is saying, and even the parts we do not yet understand, the anomalies and tensions and puzzles, are part of the message, clues to deeper truths that await our discovery. The night is deep, and the stars are shining. Somewhere out there, photons are beginning their journeys toward Earth, setting out from distant sources on voyages that will take millions or billions of years. Some of them will arrive at detectors built by future generations of astronomers, carrying information about events that have not yet happened from our perspective. Others are arriving right now, completing journeys that began before our planet existed, bringing news from the ancient universe to eyes that have only existed for a few decades. You are part of this cosmic exchange. You are a receiver of light, a destination for photons that have travelled unimaginable distances. And the wondering you are doing tonight, the gentle contemplation of mysteries and possibilities, is itself a form of participation in the universe's ongoing exploration of itself. The evidence is incomplete, the questions are open, and the light is still travelling, carrying its messages across the vast and quiet darkness between the stars. Let this be a source of peace, not frustration. The incompleteness of our knowledge is not a failure, it is an invitation. The universe has more to teach us, and we have more to learn. And somewhere in all that learning, in all that patient observation and careful analysis, we might discover something wonderful, something that changes how we understand light and space and time. But for now, rest. The work of discovery can wait for tomorrow. Tonight, it is enough to simply wonder, to hold the evidence gently, to feel the peaceful curiosity that comes from contemplating the mysteries of the cosmos. The photons are travelling, the astronomers are watching, and the universe, in all its vast and patient beauty, is revealing its secrets one observation at a time. In the gentle darkness that surrounds you, there is a concept so fundamental that we rarely stop to question it. The present moment. Now. This instant in which you are breathing, in which your heart is beating, in which these words are reaching your awareness. We live our lives in the now, moving from moment to moment, carrying our past with us as memories and imagining our futures as possibilities. The present feels solid, real, the foundation on which all our experience rests. But what is now, really? And how does the journey of light through the cosmos reveal the strange and slippery nature of this concept? These are the questions we will explore in this chapter, drifting through the philosophy of time and its connection to the light that carries all our information about the universe. And as we explore, we will find that the present is far more mysterious than it appears, and that the light reaching our eyes is always, in a sense, bringing us news from the past. Let us begin with a simple observation, one that is easy to state but profound in its implications. When you look at the sun, you're not seeing it as it is now. You're seeing it as it was about 8 minutes ago, because that is how long light takes to travel from the sun to Earth. The sun could have changed or even disappeared, and you would not know for 8 minutes until the last light from its vanished form reached your eyes. The now that you experience when you look at the sun is not the sun's now. It is your reconstruction of the sun based on light that left it in the past. This is true for everything you see. The more distant an object, the further into its past you are looking. When you see the moon, you are seeing it as it was about 1.3 seconds ago. When you see the nearest star beyond the sun, Proxima Centauri, you are seeing it as it was about 4.2 years ago. When you see the Andromeda Galaxy, the nearest large galaxy to our own Milky Way, you are seeing it as it was about 2.5 million years ago, when our ancestors were just beginning to walk upright on the African savanna. And when you look at the most distant objects that telescopes can detect, galaxies at the edge of the observable universe, you're seeing light that left those galaxies more than 13 billion years ago, when the universe was young and the first stars were just beginning to shine. You're not seeing those galaxies as they are now. You're seeing them as they were in a past so remote that the word past barely seems adequate to describe it. This means that when you look at the night sky, you are looking at a collection of different pasts, each star and galaxy presenting itself as it was at a different moment in cosmic history. The sky is not a snapshot of the present universe. It is a mosaic of the past, assembled from light that has been travelling for different amounts of time from different sources. There is no single now in the night sky. There are only many different thens, arriving at your eyes simultaneously, but carrying information about different moments in time. This is already a profound truth, one that reveals the deep connection between light and time. But our contemplation tonight invites us to go even further. What if the light from a single source arrived at different times, not just because it came from different locations, but because it took different paths through the cosmos? What if the concept of when something happened became even more uncertain, even more layered than the simple calculation of distance divided by the speed of light? Let us imagine, as we have been imagining throughout this journey, that some light takes detours through the hidden geometry of spacetime. Perhaps it wanders through extra dimensions. Perhaps it is delayed by interactions with quantum foam. Perhaps it finds its way through wormholes or other structures we have not yet discovered. If this were true, then the same cosmic event might send light to us along multiple paths, each with a different travel time. The same supernova, the same quasar flare, the same gamma-ray burst might be seen not once but multiple times, each arrival carrying the same image from the same event, but delayed by the different path it took. In such a universe, the concept of now would become even more tenuous. We would not just be seeing different objects at different times in their histories, we would potentially be seeing the same object at different times, the same event arriving in waves as different paths through the cosmos delivered their messages. The past would not be a fixed and settled thing, accessible only through the single ray of light that happened to travel straight to our detectors. The past would be layered, multiple, arriving in echoes and refractions across time. This is a beautiful and strange possibility, one that dissolves the certainty we might feel about the distinction between past and present. If light takes detours, then the now of our observations is not a single moment, but a range of moments, a smearing of time across the different paths that photons have taken to reach us. The universe would be even more interconnected than we imagined, with events in the past reaching into our present through multiple channels, multiple routes, multiple arrivals. Consider what this might mean for our perception of time itself. We experience time as flowing, as moving from past through present toward future. This is the subjective sense of time that we all share, the feeling of moments passing, of events unfolding, of life progressing from beginning toward end. But physics suggests that this flow might be an illusion, or at least not a fundamental feature of reality. In the equations that describe the universe, time does not flow. It simply is, a dimension much like the dimensions of space, along which events are located. This view of time, sometimes called the block universe, suggests that all moments exist equally. The past is not gone, it is simply elsewhere in time, just as distant places are elsewhere in space. The future is not yet to come, it already exists waiting for us to reach it. And the present, the now that feels so real and immediate, is just our particular location in this vast block of space-time, no more special or privileged than any other location. If this is true, then the light reaching us from distant stars is not just bringing news from the past, it is connecting different locations in the block universe, linking moments that are separated in time just as surely as they are separated in space. And if light takes multiple paths, arriving at multiple times, then it is creating multiple connections, multiple links between the same past event and different present moments of observation. This is a perspective that can be difficult to wrap our minds around, but it can also be strangely comforting. It suggests that the past is not lost, that the moments we have lived are still there, still real, still part of the eternal structure of space-time. The light that left those moments is still travelling, still carrying its messages across the cosmos, and in some sense those moments are still happening, still present in the block of time that contains all of history. As you rest there, breathing slowly, letting your thoughts grow quieter, consider the possibility that time is not what it seems. The present moment, this now in which you are lying and listening and drifting towards sleep, might not be the sharp edge of reality that it appears to be. It might be just one location among many, one point in a vast landscape of time through which light is eternally travelling. And the light reaching your eyes, carrying its messages from the past, might be arriving through multiple paths, each one connecting you to the same events but at different moments in your present. If you could somehow perceive all this light, all the different arrivals from the same sources, you would see the past not as a single fixed history but as a shimmering layered thing. The same events appearing again and again as different paths delivered their messages. This is not the way we normally experience time, and it might not be literally true, but it is a possibility that physics allows, a perspective that the journey of light through the cosmos reveals. And holding it gently, as we have been holding all the possibilities tonight, we can feel a kind of peace in the dissolution of our certainties. The present is not as solid as it seems, the past is not as settled as we thought, and time, that most familiar and mysterious of phenomena, is perhaps stranger than we can imagine. Let us also consider the philosophical implications of light's journey for our understanding of causality, the idea that causes precede their effects. In our everyday experience, this seems obvious. You drop a glass and then it shatters on the floor. The dropping causes the shattering, and the dropping happens before the shattering. Time flows in one direction, from causes to effects, from past to future. But if light takes detours through the cosmos, if the same event can send light along different paths that arrive at different times, then the relationship between cause and effect becomes more complex. Imagine a supernova that explodes in a distant galaxy. The light from that explosion travels toward Earth, some of it taking the direct path and some of it taking a longer path through hidden dimensions or curved spacetime. The light that takes the direct path arrives first, and we record the supernova. Then, years or centuries or millennia later, the light that took the longer path arrives, and we see the same supernova again. In what sense did the supernova cause the first observation and also the second? Both observations are effects of the same cause, but they occur at different times in our experience. The causal relationship is stretched across time, the same event rippling forward through multiple channels, affecting our present at multiple moments. Causality becomes not a simple chain from past to future, but a web, a network of connections linking events across the fabric of space-time. This is not a violation of causality in the sense that physicists worry about. The supernova still precedes both observations. The cause still comes before the effects. But it does suggest that the relationship between cause and effect is more complex than we might naively assume, that the same cause can produce multiple effects at different times depending on the paths that information takes through the cosmos. And there is another aspect of light's journey that bears on our perception of time, the relativity of simultaneity. Einstein showed that two events that appear simultaneous to one observer might not appear simultaneous to another observer who is moving relative to the first. There is no absolute now that all observers share. Each observer has their own now, their own present moment, and these presents do not necessarily coincide. This is a consequence of the finite speed of light and the structure of space-time. If two events happen at the same time according to one observer, light from those events will reach that observer simultaneously. But an observer who is moving will encounter the light from the two events at different times, because their motion changes their relationship to the travelling light. For that observer, the events did not happen at the same time. There is no objective fact of the matter about whether the events were simultaneous. It depends on the observer's state of motion. This relativity of simultaneity is not just a philosophical curiosity, it is a fundamental feature of our universe, confirmed by countless experiments and observations, and it means that the concept of now is not as simple as it seems. There is no universal present moment that the entire cosmos shares. Each location in space-time has its own now, its own slice through the block universe, and these slices are tilted and angled differently depending on the motion of the observer. If light takes detours through the cosmos, this relativity becomes even more complex. Not only is there no universal now, but the relationship between the past of distant objects and the present of our observations becomes even more uncertain. We cannot simply say that we are seeing a distant galaxy as it was a certain number of years ago, because the concept of as it was depends on how we slice up space-time, which in turn depends on our motion and the paths that light has taken. This is a dizzying perspective, one that can make us feel unmoored from the certainties we depend on. But it can also be liberating. If now is not absolute, if the present is just one location among many in the eternal block of space-time, then we are freed from the tyranny of the present moment. We can recognize that all moments are equally real, that the past is not lost and the future is not unreal, that we are simply located at one point in a vast landscape of time through which light is forever travelling. Rest in this perspective as you drift towards sleep. Let the dissolution of certainty be a source of peace rather than anxiety. The present moment is precious, not because it is the only moment that is real, but because it is the moment where you are located, the point from which you experience the cosmos, and the light reaching you from distant stars is connecting you to other moments, other locations in the block of space-time, other points in the eternal structure of reality. Perhaps some of that light has taken detours, arriving later than it should, carrying messages that are delayed by the complex paths it has taken? If so, then you are connected to those other moments in ways you cannot directly perceive, linked by photons that have wandered through the hidden geometry of the cosmos. Your now is not isolated. It is part of a web of connections that stretches across all of time and space, and perhaps there is something beautiful in this, something that makes the universe feel more interconnected and alive. We are not trapped in the present moment, moving inexorably forward as the past recedes behind us. We are part of a larger structure, a block of space-time that contains all of history, all of the future, all of the moments that light is travelling through. And the light is the thread that weaves it all together, connecting distant events to present observations, linking the past to the future through its endless journey across the cosmos. Let this thought carry you gently towards sleep. The now in which you are resting is part of a larger reality. The light reaching your eyes is connecting you to moments far removed in time, and somewhere in the vast architecture of space-time, photons are wandering through hidden pathways, carrying their messages toward destinations they cannot know. Time is strange. Light is mysterious. And you are here, in this moment, part of the same cosmos that generates both. The contemplation of time could continue indefinitely, following the philosophical threads deeper and deeper into the mysteries of existence. But for now, let us pause here, at the edge of these ideas, and allow them to settle. The relationship between light and time is profound, and the possibility that light takes detours adds new layers to that profundity. But the mysteries do not need to be solved tonight. They can remain open, invitations to future wandering, companions for future nights of contemplation. The now in which you are resting will pass, and other nows will take its place. The light that is reaching you will be absorbed, and new light will arrive. And somewhere in all that flux, all that eternal travelling of photons through space-time, there is a continuity, a connection, a thread that links all moments together. You are part of that thread. You are a node in the network of light and time, and as you drift towards sleep, you can take comfort in knowing that you are connected to everything, that the light from distant stars is always reaching toward you, that the cosmos is always speaking to those who are willing to listen. Rest now. The mysteries of time will wait, and the light, wherever it wanders, is always making its way toward eyes that might wonder about when it left and how long it has been travelling. The night is deep, and the stars are ancient. The light they send has been travelling for years or centuries or millennia, and you are here, receiving that light, wondering about its journey, part of the same vast and beautiful cosmos that creates light and time and consciousness itself. Let the wondering carry you into dreams, let the mystery be a comfort, and let the light, always travelling, always connecting, always arriving from the past into the present, be a gentle companion as you make your own journey towards sleep.